And thank you very much for joining me in this tutorial. So in this lecture, we will see how can we create our own llama models using Google Colab. Okay, so these steps can help you creating your own custom models based on the data that you will provide it, based on the data on which you would like to train your model. Okay, so the first thing that you have to do is you have to simply install these libraries. So there is bits and bytes, sentence piece, safe tensor, hugging face, right? So what we will do, we will not only create the model here in this video, we will also publish it on Hugging Face, and then we will see how can we use it in in an application. Okay, so at present, if you see here, I don't have anything like my mini llama in my Hugging Face account. Now I create a model using these steps here, and then I'll simply publish it on Hugging Face, and then I'll show it to you on Hugging Face itself how the model files comes up. Okay, so this is installed. Then I'm going with tokenizers, transformers, accelerate, save tensor. So these libraries are also required for creating models. Now comes this complete code. Okay, so I will run it first, and by the time it creates for us all the resources over here, I will explain each and everything to you guys in brief. Okay, let me run this code. So what are we doing here first is we are importing all the libraries. This is torch. Okay, so you must be knowing that for llama we use torch and tensorflow mainly. Okay, so this is something which accelerates GPU or which can deal with GPUs and CPUs well. Then comes this datasets for loading datasets and for dealing with datasets. Tokenizers is something that is used for creating tokens and for processing tokens. Then comes transformers. So these are all the things that we're using for creating the transformer, for creating the model. Okay. The first thing that we're doing here is the next thing that we're doing here is loading the dataset. So we are loading a very small dataset here, Wikitext. So it is the Wikipedia's dataset, and it is available online. You can simply pull it through this line of code. So here we are going to do only the training part. Okay, so as you can see here, it is asking for my API key. So I will go here on wand BAI, and then I will check for my API key, and that is something which I will have to fill in here. Just a second. Okay, I'm already logged in here. I will have to search for my API key. Where can I find it? So API key, this is my API key. I'm going to simply put it here. Let me just enter. Okay, so I'm logged in, and now it is going to extract the data. Fine, so the data extraction has begun, and this is something which happened through this line of code, this load data set. Okay, now the next thing that we are doing is train tokenizer. So we have defined a function here which will help all the text in the data set into tokens. As you guys know that machines and models are not capable of understanding text. So what we have to do is we have to pass everything in the form of numbers to them. Okay, so that is something which can be done with the help of tokenization easily. So this function here is nothing but a tokenizer. Okay, once this function gets executed, this tokenizer.json will get created. See, this has already got created, so I think it has got executed successfully. Then we are checking the path of this tokenizer.json. So that is what we are storing here in this tk underscore path. After that comes this tokenizer equal to pre-trained tokenizer fast, and then there are some variables to which we are passing some values. So what we are doing here, we are wrapping our custom tokenizer. Okay, this is what we have created. Now we are wrapping it into a transformer compatible object. So basically, our purpose is to create a GPT model. So for that, we have to first create a transformer compatible object. Okay, so this is how we are creating the required object. Pre-trained tokenizer fast library is the thing that we have used here. We have passed this block size as 256. So this is going to be the number of tokens which the model can read at a time. Okay, if you want, you can increase it, but because we have a limited, we have limited resources here, that is the reason I've kept it only 256. Then comes tokenize underscore fn. So this will change everything into token IDs. Token IDs means numbers. Is equal to ts.map. So it will remove the text column and it will keep only the input IDs. Fine. Then comes your group text. So what this will do, it will create a list of all the tokens. Okay, and then it will cut them into non-overlapping chunks of block size, because we have defined a block size of 256 here. Okay, so we do not want anything to be left. We want to cover everything. That is the reason this formula has been used. Based on block size, it will create chunks. Okay, and then it will do the labeling so that the model can predict the next token easily based on the tokens on which it will be trained. So fine. So this is our group text. That is what this function is doing. Then comes this lm underscore dataset. So this is the final dataset in the form of IDs that we will be using for training our model. Okay, remember this variable lm underscore dataset. Then comes this complete configuration. Okay, this is something that we will be using for configuring our GPT model. Now this is the complete configuration. We have created a model here, GPT-2 LM head model, and we have passed this config as a parameter to this. Okay, finally this data collector comes into picture. it will prepare the batches for casual language model. So it will not be a masked LM, it will be a casual LM. Okay, that is the reason we have kept this MLM as false here. Means predict the next token, not fill in the blanks. Fine. So everything is written here in brief. Just go through it once. Then we have these training hyperparameters. Okay, so we have passed this batch size is 2. Why? Because we have a limited memory here. Okay, and then this comes trainer. Then comes this trainer. So what trainer does is it handles the batching, optimization, and checkpointing. Okay, so basically its purpose is to train the GPT like model. Fine. What all things are we passing here? So we are passing this model, we are passing these arguments, this training arguments. Then we are passing this train underscore dataset, this element underscore dataset, if you remember. Right. We are passing this data collector. Okay, this data collector, and then we are also passing this tokenizer. Fine, all these things we are passing to this trainer, and finally we are training it, and a model will get prepared once the training gets successfully done. And this is what we are passing to the model so as to check whether it is working fine or not. Okay, so as you can see, the model has been trained successfully. Run these commands and show it to you. Right, so they got executed successfully. I saved the model into this my model named folder by executing these two commands, and this is the folder that has got created. Now let me just show the files to you. So these are all the model files, right? We have this JSON file. Okay, we have this generation underscore config.json. Then we have model.save tensor. Now the next task is to publish it on Hugging Face. So we will have to first log into Hugging Face. This is how we can do it. So it is asking us to enter the token. Come here in this access tokens page and then create new token. Simply come and write give a name, create token, copy the token, simply paste it over here, and then hit the login button, and you're good to go. So we have logged into the Hugging Face successfully. Now it's time for us to paste the token over here that we have created, and now we are going to come here and create a repository. Okay, so here I'm going to name it as my mini llama. I'm putting it here, and then let's create model. Fine. So as you can see, right now there is nothing. Okay, there is nothing over here. Now what I'll do is I will run this code here and let's see what will happen. So now it will create a clone. Fine, and finally it will push all these files to the repo. So the model has got successfully published on Hugging Face. Let me just refresh this page and see if it is there. Yes, so I can see the files also, I guess now. Yeah, so all the files are there, as you can see, right? And now what we will do is we will come here and we will now check this llama model that we have created. So the name of the repository is Radhe Shyam, my mini llama. Okay, this is the name of the repository. We have simply put the name here so as to use this model, and then we have simply put down some lines of code. Let's see what these lines of code will do. Okay, so this model is currently running. See, so whatever we uploaded, now everything is getting downloaded. Okay, and then it is asking us to enter something. Right. Let's see whether it will respond or not. So it has responded with some gibberish words, right? Why? Because we have trained it on a very limited data set, but it is actually responding. Okay, so this is how you can create your own models rather than depending on the ones which are already online. Fine. So if you have your own data set, you can use it. You can then create a model trained on that data set so that you can use it for your own applications which you want to function, which you want should function based on the data that you have. Okay, rather than using GPT models or using llama models or any other third party models or third party API keys. It will definitely save a lot of cost. Okay, and besides that, it will be you will have a complete control over the application like this if you have your own models in the backend. So that is it from my side in this lecture. I hope you guys enjoyed it.